Hey all, and welcome back to Stats and Stuff. This is Taylor, and today we're going to be talking about the normal distribution. Specifically, we're going to look at some of the basic characteristics that define the normal distribution, and then in the next set of videos, we're actually going to use the normal distribution to work some problems. But before we do that, we need to understand it a little bit better, kind of see what makes it tick. So I'm going to switch over to my writing screen here and say, one of the things that the normal distribution is it just looks like a bell curve. So I think we've all seen a curve that looks like this before. It's higher in the center. It tapers off towards the edges. Here I'm going to draw kind of the number line down here below it. And this bell curve is what we think of as the normal distribution. It has a center point here in the middle that we call the mean or the average, right? We'll refer to it as the mean. And it uses the Greek letter mu, which looks like this. Looks kind of like a U with a kind of a front-loaded slash on it. I don't know. But that's the Greek letter mu, and that determines, or that tells us what the mean is. Now, why do we care about the mean? The mean is the center point of the distribution. So if we had, let's say, a number line here, and we had a normal distribution over here, and a very similar normal distribution over here, the only difference between these normal distributions is their mean. This one has a mean 1, and this one has a mean 2, or a mu 1 and mu 2, right? Essentially, the mean determines the location of the normal distribution. Right? The higher the mean, the further it is up on the number line. It's kind of like the address, right? If you think of the normal distribution as a house, then its address, its location on the street, is defined by mu, right? The other characteristic that we care about is the standard deviation, or the spread of the data. So in this case, let's picture we have a normal distribution here, right, that has a mean here in the center. Now we can have another normal distribution, and I'm going to change the color so we can see this as slightly different. We can have another normal distribution that has the same center but is a little lower but more spread out. Does that make sense? So it's a little shorter and a little fatter. So kind of like me versus Matt Damon, right? I'm the shorter, fatter version of Matt Damon. In this case, that slightly wider normal distribution has a higher standard deviation, and we refer to that as sigma. So we'll write this one here as sigma 2. It looks kind of like an O with a hat on the top of it. And this one up here has sigma 1, right? And what we know out of this is that sigma 1 is less than sigma 2, right? Because it's smaller. The data is more compact around the middle. The bigger sigma is, the more spread out your data. So those two things, the mean and the standard deviation, define the normal distribution. And if you know those two things, you know everything that you need to know about it. Okay? But now here's the problem. There are an infinite number of normal distributions out there, because there's an infinite possibility of means and there's an infinite possibility of standard deviations. Therefore, there's an infinite number of normal distributions that exist. And that's a problem, right? Because we need some way to, when we're working these problems that we come up with in a little bit, we don't have an infinite source of data to look at. We need to kind of narrow down the field so we can actually work some problems. So what happens is we focus on something called the standard normal distribution. Now, the standard normal distribution is a special normal distribution that has a mean of 0 and a standard deviation of 1. So let's take a look at this, right? So the standard normal distribution It's not going to look any different just from glancing at it. But the mean is always going to be 0. And the standard deviation, which we'll just kind of write up here, sigma, is equal to 1. So what that means is you've got some kind of points out here, points out here, points out here. This is going to be sigma. This is going to be 2 sigma. This is going to be 3 sigma. You'll see this kind of graph in your textbook a lot. And what this shows us is that the further you move out, right, in the standard normal distribution, really in any normal distribution, as you move further out, you are further away from that mean. You're more standard deviations away from the mean. But that has a very important thing that we look at here in the standard normal distribution. We call these things down here z-scores. Z-scores are essentially how many standard deviations you are away from the mean. Okay, so let's do an example, and this will make more sense. So let's say that we have a normal distribution. Let's say it's an IQ test. All right, so we've got an IQ test that has a mean of 100, which is what most IQ tests have as their mean, and a standard deviation of 15. Okay, so again, what this means is if you score a 100 on the IQ test, you're normal, you're average. Okay, if you score higher than that, you're above average. If you score below that, you are below average. And the sigma tells us how spread out that data is. So let's come here and take a look. So I'm just going to draw this out, and this doesn't have to be perfect. Wow, that one actually looks pretty good. Kind of proud of myself about that one. And we'll put here in the middle 100. Okay. This is what the normal distribution looks like. And again, we can kind of draw some pictures over here. I mean, some lines, and say this is like 115. This is like 130, 145. And so what we end up seeing, right, is that you're much, much, much less likely to get a score of 145 on the IQ test than you are to get a score of 100. It's much, much lower. Okay, and then you could do this going the other direction as well. All I did here was add the difference between here is sigma, right? Sigma. And so what we want to do is we want to change this distribution into the standard normal distribution, because that's what we're going to need to do for all of the problems as we work them out later. So to do that, we need to turn this, say, 115 into a z-score. And we use something called the z formula for this. So z is equal to x minus mu over sigma. Okay, so we can turn any x into a z using this formula. So what is the z-score of 115? Well, we can come here and say the z-score of 115 is 115, that's our x, minus mu, which is 100, divided by sigma, which is 15, right? That was just given to us. And so 115 minus 100 is 15, divided by 15, and that's a z-score of 1. So let's make sure we understand what that z-score is telling us. That is telling us that that point, 115, is one standard deviation. That's what the z-score means. One standard deviation above average, which we knew, right? That's why we drew it there. But that's what the z-score tells us. Let's say we had another point. Let's make it something a little easy. Let's say at 120, right? So we've got a point here of 120. And we want to figure out what its z-score is. Well, how do we figure out its z-score? So we're going to use this exact same formula. Z is equal to 120 minus 100 over 15, which is 20 over 15, which is 4/3, which is 1.33. So a IQ score of 120 is 1.33 standard deviations above average, right? That's what the z-score tells us. And that way we can compare any normal distribution to any other normal distribution, right? Because in a normal distribution, almost all, when I say almost all, like 99% of all of the data is within 3 standard deviations of the mean, plus or minus 3 standard deviations. Okay? So if you scored, let's say, a score on the IQ test that had a z-score of 4, then all of a sudden we don't even know, we don't have to know what the actual score is. Let's say it was a weird IQ test that didn't have a mean of 100, but if you knew that you scored a z-score of 4, all of a sudden you're at the very, very top, because in a normal distribution, a z-score of 4 is way off to the right, right? Because almost all the data in a normal distribution is within 3 standard deviations of the mean. Okay? So these kinds of things, the standard normal distribution allows us to compare different normal distributions to each other, and allows us to use some standardized tools, like we'll see in a minute, called a z-table, and we can go look up areas and find exactly what the probability of different events are. Okay, so all this together allows us to use the standard normal distribution to solve some problems. We're going to make some more videos to show you how to do that in just a second. So stick around, like and subscribe, and we'll see you back in a minute. Bye.